So today we're going to start learning about what is the heart and soul of Scratch, which is blocks. And eventually we're going to move into lists. And that's where stuff gets really powerful. Blocks are very similar to what we call functions or methods in other coding languages. So this is an important sort of scheme that you need to understand if you want to take on any sort of future coding. So why do we use blocks? Three main reasons. First of all, we want to make the code more organized or readable. So when you're looking at somebody's blocks of code, you can interpret and understand what it is they're trying to achieve. We want to also be able to, number two, break out a complicated chunk of code and to develop it and test it separately. So there might be some behavior you want as part of your code, so you work on just that one behavior, you get it working, and once it's working, you plug it back into your code and then you can run it. And finally, you might want to make your code more efficient by requiring fewer lines of code to perform a repetitive task. So a block can perform a repetitive task. I'm going to show you little examples of each of those. So first of all, let's make your blocks readable. Now, if I want to make a game, I will have some sort of basic building blocks as part of the game. And so I can actually create these blocks without even programming that. It's sort of like writing an outline for a paper. You have several ideas you want to present, and so you have your outline, and then you kind of flesh out the different parts of your outline. So in this game, I'm going to say repeat until game over equals true. So that's a little flag that's going to be running until I'm done. Initialize my game. That's going to set some variables, kind of get everything started, get the stage set, whatever I need to do. Then user input is probably where I'm going to collect some input from somebody who's playing the game. Then I'm going to compare what the user put in with what the computer decided. So this might be rock, paper, scissors. It might be tic-tac-toe. It might be some sort of complicated game. And then once I have checked to see if a winner, then I've updated the score. Either I get points or the computer gets points. And then we play again. So we'll complete this little loop. So by just having these little blocks of code, we don't know what's happening in the user input block. We just know that it works. And that's the idea. You want to structure your code that has just simple little chunks that you then develop each of those separately. So if you create blocks this way, then it's a lot easier to read it, to come back and modify it later. Maybe there's a part of it like your check winner code, like that's really great code and you want to use that in a different game that you're going to play, or your update score. Like there might be code that you write that you want to use again. So by creating code that has sub-programs or subroutines, as these might be called, or custom blocks, then you can access them and use them again later. Okay, moving on. So take a look at this code and try to think about what it does. You could almost call this like a little bit of pseudocode, right? This isn't, it's not written in specific tasks, but you get a sense of what's happening. How many classes total? So you're going to ask somebody how many classes they have. So maybe they have 3 classes. So answer is going to get set equal to 3. Then you're going to repeat 3 times because num classes is set equal to the answer. Okay, so how many students are in the class? And then wait. So now what you're going to do is for each of the classes, there might be, I don't know, 15 kids in the class. Now you're going to go and you're going to collect all of the names. Your block is going to be the name collector block. And then you're going to take those names that you just collected and you're going to alphabetize them and put them in a list. So we'll talk about lists next week. So this code is going to take a number of classes and do the same behavior however many times for classes that you have. And then at the very end, it's going to combine all of them into one. So that's another separate block. So you get a sense that this is nice and neat and clean and relatively short, and so you can follow what's going to be happening in the code. When you write quality programs, you should have no more than 10 lines of code below your green flag. Everything else, if it gets more complicated, should be broken into little blocks or subroutines. Okay, so how do you do a block? Within your Scratch menu, you have this button here that says More Blocks. That's where you get to define it. Here's one that we have defined. We have called it Square, which should tell you exactly what it does. And it has this little thing here that's kind of purple called side. That's actually called a parameter. It's sort of a variable that is local to just this particular block or function. So we're going to use that number. It gets passed in when the block gets called. So maybe the side would be 10 steps. And so this is going to move 10 steps. So you're going to create a square that is 10 steps by 10 steps by 10 steps by 10 steps. Okay. When you first define your block, you're going to click on this little blue button. That's how you define a block. It's going to ask you if you want to do any parameters. And in this case, we create one here. Parameter is this value right here. Parameter is a piece of information that we're going to pass into our our block or our function, and then that's going to be used as part of the function. Now, some blocks have parameters, some don't. They just might be doing some specific task, but they don't need a number or a value or a string or anything to be input for them to work, but some do. You get to play around with both types. So we're using that same square with a couple of others. So here's that original square that we built before. And now we're going to call this code up here that will actually run the square code but pass in different numbers. So this is going to draw, it looks like 4 different squares. One's going to be 40, 60, 80, and then 100. So they're going to get progressively larger squares. And then this function over here, this block, is going to call squares. So here it repeats a certain number of times. It's going to call squares every time. And every time it calls it, it's going to rotate a little bit. So let's run that code and see what it does. So here is the code. If I click the green flag, it's going to draw 1 square. So there we go. It draws 1 square. So now I'm going to do spacebar to clear the screen. And if I hit S, then I get 1, 2, 3, 4 squares, and then 1, 2, 3, 4, and 1, 2, 3, 4. This is the rotated squares. It draws 4, and then it rotates and draws another 4, etc. And so we get this beautiful pattern. I call that a spirograph, because in the old days we used to have fun toys that you can do geometrical patterns called a spirograph. So you're going to play around and do something like this as part of your pair programming. Okay. Oh, let's look back in the code. Sorry. I want to look back inside, and here is the code that we talked about. Here is the square. That's how you draw a square. Here's the one that does the 4 different squares, and then this is the code that rotates it. If you want to access this code and take a look at it, you can. It is right here under sample block coding, so feel free to check that out. Okay, that's the main program, so we looked at that. We're good. Okay, another reason to use blocks of code is if you want to repeat something many, many times. Then you can create a little block of code that will perform a very specific task so you don't have to code it a zillion times. So let's take a look at code like that. So here is an example. If you take a look at this, I've got really long chunk of code because I have all these things and they're exactly the same. So this is very inefficient, but it does get the job done. This says select D, so I'm going to click on D. And we have a little costume that's jumping around. I have it timed so that within the repeat that weight is a little bit smaller or larger to make the code slow motion. So I can synchronize the dance with the beat. And that's fine, I can do that. It's just kind of tedious to have all these lines of code. So let's instead think about a simpler way to code it. In this case, I just develop a block called flip me with the speed. And I'm going to pass in that value of 0.1 or 0.2 or 0.01, and that is what's going to tell it how fast it should flip, whether it's going to be slow motion or fast motion. And then instead of having all of that code, I'm just going to call flip me, and I'm going to pass that little value. So this is an example of having the same exact behavior as this one, but instead of having all of these lines of code, which is really a pain if you ever want to make a change. Like if I want to make a change to the flip me, I can make it within the block and I don't have to make it to every single copy of the version that it's trying to emulate here. So much more efficient to code this way. Another type of repetitive task is doing a mathematical formula. So if you want to regularly be calculating the distance between two things, you're going to have a code coming up next week that will require you to do that. So today, in this lab, you're going to build a distance formula block that passes in an x1, y1, x2, y2, and calculates the distance. You already did that once before, but now you're going to do it within a block. You're going to have another sort of feet to miles conversion, and then I threw in future value, which is a pretty complicated chunk of math that I'm going to encourage you to do if you can handle it. It's not required, but it's optional, so go for it if that's up your alley. Okay, finally, we're going to do a little code with me. Okay, so that means I've created a little template, and you guys are going to go ahead and grab it and then remix it. So here's where you find the remix. You want to grab it right here and do the dog years remix it. So click right there. Pause the video if you need to, so you get yourself all set up. You're going to open this thing. You see a little puppy in an area here, and you're going to go ahead and remix. I can't remix this because I own it, but you can. So this is what you're going to do. When you look inside, you're going to see code that looks like this. And if you run it right now, what it does is it says, how old are you? And so then you can put your age in. So you put in 15, and so you're 15 years old. Now it doesn't do anything, but what you want it to do is tell you how old you are in dog years. So we are together going to build a little block that will allow you to do that. So let's try it. Here we go. We're going to go to more blocks, and we're going to make a block, and we're going to call it dog years. And we want to pass in your people years. In other words, how old you are. So we want to pass in a variable, and we're going to call, well, let's just be a number. So I'm just going to hit a number, and we're going to call it people years, because that's the number we want to pass into our little block. So here's our block down here. Now, we got to pass that in, and we're going to call it. So first of all, let's just for fun come up with a couple of variables. We have dog years, and let's do another one. We're going to call it people years, just so we keep track. So right now, we've just collected our value for an answer. So you are 15 years old. So let's set people years. We're going to set people years to whatever that answer was. Answer. So there we go. Set people years to answer. Now we don't need to do this, but it's just kind of clean coding to keep track of the different years in a variable. Okay, so people years is this. So now what we're going to do, so it says you are 15 years old. We could also change that out and say you are people years old. That kind of makes it clean. Okay, now we want to figure out how many years you are in dog years. And we've defined a function, but we haven't written it yet. And we're going to call that block, and we're going to call the block dog years, and you're going to send it the value of people years. So we're going to go people years, and we're going to send it in there. So people years, whatever value that is, in this case 15, is going to show up inside this block right here. This people years is going to now be set equal to 15 when we call it. Now, hopefully you might know this is going to be really simple. So it's like, why would I do a block for this? Just because I'm showing you how to use blocks. So there's probably an easier way to do it by just having a formula, but that's okay. So set your people years. Your dog years is going to be, if you know the formula, it is going to be however many people years you have times 7. So you grab people years, that's what's getting passed in, and you go boop, and you stick it right there. People years times 7. So you're setting dog years equal to that. So dog years is going to be people years times 7, whatever that is. And then once you have done that little multiplication, this is a super simple formula. You're going to do more complicated ones with distance formula, etc. Now, when you go ahead and do this, it's going to say that means you are dog years old in dog years, because dog years, since this block has been run, dog years is now going to set equal to the correct value. Okay, now this does not seem like a simplified way of using a block, but that's okay. I just want you to get familiar with how you create them and play around with them. So let's run it. We're going to go green flag. So how old are you? I'm 15. So you are 15 years old. That means you are 105 years old in dog years. Okay, so that's the idea. All right, so you are now ready to go on lab number 5.